Hello everyone. Today I am going to explain the most important theorem of chapter triangles, that is basic proportionality theorem. इस थ्योरम को अच्छे से समझ लीजिए और बार बार प्रैक्टिस करिए ताकि एग्जाम में कोई गलती ना हो. Let's see what is the theorem. Basic proportionality theorem is also known as Thales theorem. In short, we say this theorem as BPT theorem. So the BPT theorem states if a line is drawn parallel to one side of a triangle, that is if D is drawn parallel to BC to intersect the other two sides in distinct points, that is AB and AC at distinct points, that is D, E. So it means D is intersecting AB and AC at point D and E. Then the other two sides are divided in the same ratio. So the sides AB and AC are divided in the same ratio. That means AD upon DB will be equal to AE upon EC. So in short, this theorem means if D is parallel to BC, it is given here D is parallel to BC, then AD upon DB will be equal to AE upon EC. So this is what we need to prove. If this is given, then we need to prove that the sides are proportional. So to prove this theorem, you should start with writing the statement. That is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. This statement to be written before proving the theorem. So now, what is given? Given is D is parallel to BC. Then write what to prove. To prove AD upon DB is equal to AE upon EC. Okay, to prove this theorem, we require construction. So for construction, you need to draw DM perpendicular to AE. So write draw DM perpendicular to AE. Here you can write either AE or AC. And draw EN perpendicular to AD. Draw EN perpendicular to AD. So in place of AD, you can write AB as well. And then join B to E, join B and DC. So this construction is required to prove this theorem. Now let's prove. So write proof here. Okay, to prove any theorem, we get the hint from what to prove. So just you see here, AD is the part of triangle ADE and DB is the part of triangle DBE. And we have the height also given here in the triangle. So for triangle where base and height is there, so we will take use of area of triangle. That is half into base into height. To get these sides AD and DB, we are going to use area of triangle. AD is a part of triangle ADE. So that is ADE upon area of triangle. DB is a part of triangle DBE. So I'm going to write here DBE. Use this formula. Area of triangle ADE is half into, here the base we want AD. So I'm going to take the base as AD into height. So now just be careful while taking the height. If the base is AD, then the corresponding height will be EN. This will be the corresponding height. So in the other way, we can say that if the base is AD and the vertex opposite to this base is E. So the perpendicular to be drawn from this vertex to get the height. So EN is the height of this triangle when base is AD. Upon, now for here, area of triangle DBE is again half into, we require the base as DB. So we are going to take this base DB into now the height. For height, the perpendicular to be drawn from the vertex which is opposite to the base. So here E is the vertex which is opposite to the base DB. So from here the perpendicular to be drawn. So here EN is the height of this triangle DBE when the base is BD. So here half into base into height, where height is EN. And just now you may be thinking that why the height is outside the triangle. Whenever a triangle is an obtuse angle triangle and the perpendicular is drawn from the vertex of acute angle, then the height lies outside the triangle. So now cancel what is common. EN and EN gets cancelled. So we are left with area of triangle ADE upon area of triangle DBE is equal to AD upon DB. Mark it as first equation. Now just check the right hand side. So here the same process as we have done there, the same process we are going to do for this side. So just check, A is a part of which triangle? A is a part of triangle ADE. So right here, area of triangle ADE upon EC is the part of triangle DEC. So write area of triangle DEC. Now write the formula here. Area of triangle ADE is half into. Now we want the base AE. So for this triangle ADE, we are going to take the base as AE. And as I said, if the base is AE, then the corresponding height will be DM. That is the perpendicular drawn from the vertex which is opposite to the base. That will be the height. So here the height is DM. Upon, for this area of triangle DEC, half into base we want it as EC. So we are going to write the base as EC into now height. Again this triangle DEC is an obtuse angle triangle. So here the height will be the vertex which is opposite to the base, the perpendicular drawn from that vertex. So this will be the height, that is DM. So for this EC, the corresponding height is DM. Cancel the common, half and half gets cancelled, DM and DM gets cancelled. So write what is left. Area of triangle ADE upon area of triangle DEC will be equal to AE upon EC. Mark it as second equation. Observe the first equation and the second equation. We need to prove AD upon DB is equal to AE upon EC. So we need to prove AD upon DB is equal to AE upon EC. So to prove the right hand side equal, we need to show that the left hand sides are also equal. Just check here in the numerator of first equation we have area of triangle ADE, and here in for second equation in the numerator we have area of triangle ADE. Both are same, but in the denominator we have here area of triangle DBE in first equation and area of triangle DEC in second equation. So these two are not same. So with here right now we can't say that the left hand sides are equal. So in that case, to make the left hand sides equal, we need to prove area of DBE equal to area of DEC. Observe in the figure that triangle DBE and triangle DEC both have the common base, that is D. So I'm writing here triangle DBE and triangle DEC both have the common base, that is D. And just you observe this also here, the triangle DBE and triangle DEC, they lie between the same पैरेलल्स. कैसे? अभी देखिए DBE का बेस D है जो एक पैरेलल लाइन पर है और उसका जो वर्टेक्स है वो दूसरे पैरेलल लाइन पर है. उसी तरह ट्रायंगल DEC का जो बेस है वो D एक पैरेलल लाइन पर है और जो वर्टेक्स है वो दूसरे पैरेलल लाइन पर है. सो ये जो दोनों ट्रायंगल हैं, ट्रायंगल DBE और DEC, दोनों इन पैरेलल लाइन पे लाई करते हैं. सो दे लाई बिटवीन द सेम पैरेलल्स, दैट इज D and BC. In class 9, they have studied one of the theorems that if two triangles are on the same base and between the same parallels, then they are equal in areas. So I'm writing here, since triangle DBE and triangle DEC are on the same base and between the same parallels, therefore area of triangle DBE will be equal to area of triangle DEC. Let me explain once again to you. Since the triangle DBE and the triangle DEC are on the same base and between the same parallels, therefore the area of triangle DBE is equal to the area of triangle DEC. So this is a theorem we have studied in class 9 and we are using it to prove the BPT theorem. So mark this as third equation. Now just see the second and third equation. In second and third equation, in place of DEC, I hope we can replace that with triangle DBE. So I'm replacing DEC with triangle DBE. So I'm writing the same equation again. Area of triangle ADE upon, in place of DEC I'm writing DBE. That area of triangle DBE because DBE is equal to DEC. So in place of DEC, I have mentioned it as triangle DBE, which is equal to AE upon EC. Mark this as fourth equation. So now compare the first and the fourth equation. I'm taking this equation down. Compare this first equation and the fourth equation. So just observe here, area of triangle ADE upon area of triangle DBE is there in the left hand side, and here also area of triangle ADE upon DBE is there in the left hand side. So if left hand sides are equal, then right hand sides are also equal. So from first and fourth equation we get, from equation 1 and equation 4, we get that AE upon EC is equal to AD upon DB. So this is the way we prove basic proportionality theorem. So the first equation, the second equation, and the third equation to be mentioned to prove the basic proportionality theorem, that if D is parallel to BC, then AD upon DB will be equal to AE upon EC. So this is what the BPT theorem. Do like, share and subscribe the channel to get updated with more interesting videos. Thank you.